What is rate determining step? Rate determining step is the slowest step of complex reaction. In place of concentration, I'll put mole per liter, time second into, in place of concentration, I'll put mole per liter. And here N is order. N is equal to what? Order. What is molecularity reaction? Is the total number of reacting species. It may be atoms, ions or molecule involved in a balanced chemical equation is known as molecularity. Hello everyone. I am Renuka Ashok, Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. My dear students, today the second session of chapter Chemical Kinetics. Second session of chapter Chemical Kinetics. In the previous session, that is in the first session, I discussed about, had given introduction about chemical kinetics. Then I discussed about rate. In rate, I discussed about two types of rate, average rate as well as what instantaneous rate, and the factors which influence the rate of the reaction as well as rate constant of a reaction and the characteristic of rate constant. That means in the first class, I completely explained about what are the basic terms required to explain chemical kinetics. Okay. Now, in this session is a very important concept as well as new terms we are going to heard in physical chemistry. That is, one is order and the one is what? Molecularity. Therefore, in today's session, I am going to explain order of a reaction as well as molecularity of a reaction. Order of reaction as well as second one, molecularity of a reaction. Molecularity of a reaction. Order and molecularity. Today's session, I am going to explain two terms, order and molecularity. Order of a reaction as well as molecularity of a reaction. Okay. Order, if I want to explain order of a reaction, order of a reaction, already you know that a general reaction of the type A moles of A reacts with B moles of B give rise to C moles of C as well as D moles of D, where A, B, C, D are called stoichiometric coefficients. Small a, B, C and D are called stoichiometric coefficients of reactants and products. Small a, B, C, D are called stoichiometric coefficients of reactants and what? Product. If I apply law of mass action, to this reaction, so rate is directly proportional to, velocity of a reaction is directly proportional to product of the molar concentration of the reactants. That is, which are reactants here? A and B. Product of the molar concentration of the reactant, that is molar concentration of A into molar concentration of B, and raised to the power is equal to X and Y. Raised to the power is equal to X and Y. This X and Y may or may not be equal to, may or may not be equal to stoichiometric coefficients, may or may not be equal to stoichiometric coefficients. Okay. So, therefore, I will write X and Y. When I add the power, that is X plus Y, it is overall order of the reaction. Therefore, to get order of a reaction, you should add powers of the molar concentration of the reactant. I have to take a sum of powers of the molar concentration of the reactant. Therefore, what is overall order of the reaction? X plus Y. X is the order of a reaction with respect to A. Y is the order of the reaction with respect to B. What is X? X is the order of the reaction with respect to A. Y is the order of the reaction with respect to B. X plus Y is the overall order. X plus Y is the overall order. Therefore, what is order? Define order, or what is order of the reaction? It's a very, very important question for your board as well as concern for your competitive exam. They'll give one equation, you have to find out order of the reaction. Therefore, how do you define order of the reaction? Order of the reaction is defined as it is the sum of the powers of the concentration of the reactant in rate law. Rate expression is called as order of the reaction. Now, this is called as what? Rate law, rate expression or rate equation. Rate law, this is called as what? Previous class I expressed that. It is called as rate law, rate law, rate expression, rate law, rate expression, rate law, rate expression, as well as rate equation, as well as rate equation. Sum of the powers of the, sum of the SUM, sum of the powers of the molar concentration of the reactants present in rate law, rate expression as well as rate equation is called as what? Order of the reaction. It is a 1 mark very important question, as well as in your competitive they'll give one rate law, rate expression, and you have to find out order. If you want to find out order of the any reaction, you should add powers of the molar concentration of the reactants, powers of the molar concentration of the reactant. Order of the reaction, it may be 0, 1, 2, 3 as well as it's a fraction. Okay, the values of order, it may be 0, 1, 2, 3 up to n, as well as it is also fraction, Okay, so order always may not be, don't think that order is always whole number. Order may be 0 or order it is also fraction, as well as order is whole number. Once again, I am going to repeat order of the reaction. If you want to find out order of the reaction, you need rate law or rate expression. How do you write rate law and rate expression? By taking an application of law of mass action. Which law? Law of mass action. What's the statement of law of mass action? At constant temperature, the velocity of a chemical reaction is directly proportional to product of the active masses of the reactants. Product of the active masses of the reactant or product of the molar concentration of the reactant raised to the power is equal to, may or may not be equal to stoichiometry coefficient. After writing rate law, rate expression as well as rate equation, you add power of the molar concentration of the reactant. That value is nothing but order. But don't think that order is always whole number. It may be 0 or it is what? Fraction. Therefore, what is the definition for order? Order is defined as, it is the SUM, sum of the powers of the molar concentration of the reactants present in rate law, rate expression as well as rate equation. Okay. A balanced chemical equation never gives us a true picture of how reaction takes place, since rarely a reaction gets completed in one step. You are thinking that, my dear students, all the chemical reaction which takes place here in this universe, or you are thinking that they takes place in single step. For example, when you consider organic chemistry first PUC hydrocarbon chapter, chlorination of methane. Is it chlorination of methane takes place by one step? No, it takes place by 4 steps. First it will form methyl chloride, next it will form methylene chloride, next it will form chloroform, and next it will form carbon tetrachloride. If I write reaction mechanism for that reaction, each step takes place by sub-steps like initiation, propagation and what? Termination. Similarly, carbon reacts with oxygen to form carbon dioxide. It does not take place by single step. First carbon reacts with oxygen, it will form carbon monoxide. That carbon monoxide reacts further with oxygen, it will form what? Carbon dioxide. Therefore, all the reaction never takes place by one step. Some reactions takes place by one step. Some reactions takes place by one step. Some reactions takes place by 2 or more steps. Any reaction which takes place by one step, such reactions are called as elementary reactions. Such reactions are called as what? Elementary reaction. 2 or more steps, they are called as complex reaction. They are called as what? Complex reaction. Therefore, based on number of steps, there are 2 types of chemical reaction. One is elementary reaction, second one is complex reaction. What are elementary reaction? Elementary reactions are those which takes place by single step. Complex reactions are those which takes place by 2 or more steps. My dear student, when A sequence of elementary reaction give as product. The reactions are called as what? Complex reaction. Now, one reaction, reactant give rise to product. It takes place by 3 steps. Step 1, step 2, step 3. Step 1, step 2, step 3. So, in that, you have to consider, this is known as complex reaction because it takes place by 3 steps. Out of these steps, you have to find out which one is the slowest step. Which one is the slowest step? For example, here second step is very slowest step. This step is called as rate determining step. This step is called as what? Rate determining step. From this step only, we have to find out order and molecularity. We have to find out order and what? Molecularity. Again, what is rate determining step? Rate determining step is the slowest step of complex reaction. Rate determining step is the slowest step of complex reaction. Slowest step of complex reaction which is used to find out order and molecularity. Therefore, once again I will repeat, depending upon number of steps, how many types of reaction? 2 types of reaction. One is elementary reaction, second one complex reaction. Based on number of steps, my dear students, how many reactions are there? 2 reactions, elementary reaction as well as what? Complex reaction. What are elementary reaction? Elementary reactions are those which takes place by 1 step. So, complex reactions are those which takes place by 2 or more steps, or a sequence of elementary reactions are called as what? Complex reaction. In complex reaction, when the reaction takes place by 2 or more steps, find out which is the slowest step. Why you had to find out slowest step? That step is used to find out order and molecularity, and that step is called as rate determining step. Rate determining step. Example for consecutive reactions. Example for complex reactions are consecutive reaction. So, example for that, oxidation of ethane to carbon dioxide and water. Oxidation of ethane. What's the formula of ethane? C2H6. When it undergo oxidize, it will form carbon dioxide and water. It proceeds through so many intermediate steps in which alcohol, aldehyde and acid are formed. Okay. What's the final product? Oxidation of ethane. Oxidation of ethane. So, the final products are carbon dioxide and water. But intermediate steps, there is a formation of what? Alcohol, aldehyde and acid. Reverse reactions as well as side reaction. For example, nitration of phenol yields orthonitrophenol and paranitrophenol. You know that in case of organic chemistry, I discussed under haloalkanes and haloarenes. When chlorobenzene, when phenol, they undergo nitration, they'll give mixture of 2 products. One is ortho, another one is para, in which para is major. Similarly, all side reaction. Example, when phenol undergo nitration, it gives rise to mixture of orthonitrophenol and paranitrophenol. These all are beautiful example for what? Complex reaction. Again, which are example for complex reaction? Example for complex reactions are consecutive reaction, reverse reaction as well as side reaction. Therefore, in reaction, there are how many type of reaction depending upon number of steps? 2 reaction, elementary and what? Complex. Elementary means which takes place by single step. Complex means which takes place by 2 or more steps. What is order of the reaction? Order of the reaction is defined as it is the sum of the SUM, sum of the powers of the molar concentration of the reactant present in rate law, rate expression or rate equation. Okay. Next, let us consider unit of rate constant. Unit of rate constant. What's the symbol used for rate constant? Symbol used for rate constant is K, capital K. So, what's the unit of rate constant? How do you find out the unit of rate constant? Already you know that. What's the unit of velocity of a reaction? The unit of velocity of a reaction is mole per liter per second. Mole per liter per second. Now I am finding unit of rate constant. Unit of rate constant K. For that I am going to take general reaction. A moles of A reacts with B moles of B, give rise to C moles of C and D moles of D. Applying law of mass action, rate is equal to K into molar concentration of A to the power of X into molar concentration of B to the power of Y. If you add the power X and Y, which is equal to N, which is order of the reaction. Which notation is used to denote the order of the reaction? Small n. In chemical kinetics, if I use small n, it indicates order of the reaction. Order of the reaction. Now, let us consider V is equal to K into A to the power of X into B to the power of Y. Okay. Now, if I rearranging, what happens? K is equal to, what is V? V is rate, and these two terms goes to the denominator, A to the power of X into B to the power of Y. Here, K is equal to rate divided by molar concentration of A to the power of X into molar concentration of B to the power of Y. So, you already know that was the one I can substitute in place of rate. Already in the first session, I had given definition for rate of reaction. Rate of reaction is defined as change in rate of change of concentration with respect to unit time. That is, rate is equal to change in concentration divided by time. Rate is equal to change in concentration divided by time. Therefore, concentration divided by time 1 by, this is molar concentration of A and molar concentration of B, that I will take concentration. You know that X and Y is equal to N, which is equal to order of the reaction, which is equal to, therefore, I will put N here. Therefore, the expression will become what? Concentration divided by time into 1 by concentration to the power of N. 1 by concentration to the power of N. If I put SI units of concentration as mole per liter, and for time it is second. So, how can you get units of rate constant? Let us consider zero order reaction. What is it? Zero order? Zero. Therefore, in place of concentration, I will put mole per liter, time second into, in place of concentration, I will put mole per liter, and here N is order. N is equal to what? Order. Zero order means what's the value of N? 0. Therefore, mole to the power of liter, it will become any number to the power of 0, it will become 1. Therefore, when second goes to numerator, it will become what? Mole per liter per second. What is the unit of velocity constant of zero order reaction? The unit of velocity constant or rate constant. Velocity constant or what? Velocity constant or rate constant. The unit of rate constant or velocity constant of zero order reaction is mole per liter per second. Mole per liter per second. What's the unit for zero order reaction? Velocity constant, mole per liter per second. It is also a unit for velocity of a reaction. Velocity of a reaction as well as unit of velocity constant of zero order reaction, both are same, that is mole per liter per second. Next, I will consider first order reaction. What's the order of first order reaction? Order is equal to 1. So, now in place of concentration, I will put mole per liter. In place of concentration, I will put mole per liter. In place of time, I will put second into 1 by, in place of concentration, I will put mole per liter, and order is 1, This is get cancelled, second goes to numerator, it will become what? Per second, what's the unit of rate constant of first order reaction? The unit of rate constant of first order reaction is per second. Similarly, move on to second order. What's the second order? What's the order value? 2. In the place of concentration, I will put mole per liter, and in place of time, I will put second into 1 by concentration mole per liter, and it is second order, I will put 2 here. Now, when 2 comes here, it will become mole square liter to the power of minus 2. Mole square liter to the power of minus 2. Mole square, if it goes to the numerator, it will become mole to the power of minus 2. Mole to the minus 2, here it is 1, it will become minus 1. And similarly, liter to the power of minus 2, it goes to the numerator, it will become liter square. Liter square, 2 minus 1 is 1, and second goes to numerator, it will become per second. What's the unit of rate constant of second order reaction? It is mole to the power of -1 liter to the power of 1 per second. What's the unit of rate constant of second order reaction? Mole to the power of -1 liter to the power of 1 per second. What's the unit of rate constant for zero order reaction? Mole per liter per second. What's the unit of rate constant of first order reaction? Per second. What's the unit of rate constant of second order reaction? It is mole to the power of -1 liter to the power of 1 per second. If I compare this with what's the unit of nth order? What's the rate constant for nth order? Mole to the power of 1 minus n liter to the power of n minus 1 per second. What's the unit of velocity constant for nth order reaction? The unit of velocity constant of nth order reaction is mole to the power of 1 minus n liter to the power of n minus 1 per second. Mole to the power of 1 minus n liter to the power of n minus 1 per second is the unit of rate constant for which order? Nth order. Now, based on order, the reactions are classified into different types: zero order, first order, second order, up to nth order. Zero order, first order. But for your PU syllabus, we have two reactions, zero order as well as what? First order. Definition as well as what? Example. This is a 2-mark very important question for your board. So, what are zero order reaction? Give example. What are zero order reactions? Give example. Is a very important, very important question for your board. So, 2-mark. What are zero order reactions? Give example. So, what are zero order reaction? Velocity is direct. Zero order means the molar concentration of the reactant whose power will become what? Zero. Therefore, velocity of a chemical reaction is directly proportional to zero power of the molar concentration of the reactant. Zero power of the molar concentration of the reactant. What are zero order reaction? These are chemical reaction in which velocity is directly proportional to zero power of the molar concentration of the reactant. And one more definition I can give for zero order reaction. As you know, the velocity of a chemical reaction is directly proportional to concentration. As concentration increases, the velocity also increases. For example, in the laboratory, if the reaction is not possible with dilute sulfuric acid, we'll switch over to what? Concentrated sulfuric acid. That means in the laboratory or in practical classes, if the reaction is not possible with dilute condition, we'll increase its what? Concentration. That means what? The velocity of a chemical reaction is directly proportional to what? Concentration. But few reactions are there whose velocity is independent of molar concentration of the reactant. The velocity does not depend on what? Concentration. Velocity is independent of concentration. Such reactions are called as what? Zero order reaction. My dear student, zero order reaction can be defined in how many ways? Two ways. How many ways? Two ways. One is, it is the velocity of a chemical reaction is directly proportional to zero power of the molar concentration of the reactant. Zero power of the molar concentration of the reactant, or velocity of a chemical reaction is independent of molar concentration of the reactant. Molar concentration of the reactant. Example for zero order reaction: decomposition of ammonia to nitrogen and hydrogen. Decomposition of ammonia, decomposition of gaseous ammonia to hydrogen and what? Nitrogen on the surface of hot platinum or hot molybdenum. On the surface of hot platinum or hot molybdenum. So, decomposition of ammonia on the surface of hot platinum and hot molybdenum. Hage thermal decomposition of hydrogen iodide on the gold surface. Thermal decomposition of hydrogen iodide on the gold surface. Hydrogen iodide ಆದಾಗ ಯಾವ್ದು ತಗೊಳ್ಳಿ? Gold. Ammonia ಇದ್ದಾಗ ಯಾವ್ದು ತಗೊಳ್ಳಿ? Hot platinum or hot molybdenum. Okay. And hydrogen reacts with chlorine in the presence of diffused sunlight. In the presence of what? Diffused sunlight. One, you can say all photochemical reactions. All photochemical reactions. What is the meaning of photochemical reactions? Photochemical reactions are the reactions which takes place in the presence of sunlight. They are beautiful example for what? Zero order reaction, as well as all enzyme catalyzed reaction. Enzyme in general, enzyme catalyzed reaction, that means the reactions which takes place in the presence of enzyme as a catalyst, they comes under which order? Zero order reaction, zero order reaction. Therefore, photochemical reactions, photochemical reaction. What's the meaning of photochemical reaction? Photochemical reactions are those, the reactions takes place in the presence of what? Sunlight, as well as enzyme catalyzed reaction. They are beautiful example for what? Zero order reaction. 2 mark, very important question. What are zero order reactions? Give example. What are zero order reaction? Whose velocity is directly proportional to 0 power of the molar concentration of the reactant, or whose velocity does not depends upon what? Concentration. Such reactions are called as what? Zero order reaction. Example for zero order reaction: decomposition of gaseous ammonia. Decomposition of gaseous ammonia on the surface of hot platinum or hot molybdenum. Decomposition of hydrogen iodide on the surface of gold. Hydrogen and chlorine react to form hydrogen chloride in the presence of diffuse sunlight. These all are example for what? Zero order reaction. Next, first order reaction. First order reaction. Here, velocity is directly proportional to first power of the molar concentration of the reactant. The velocity of a chemical reaction or rate of a chemical reaction directly proportional to first power of the molar concentration of the reactant. Example, hydrogenation of ethene, all natural and artificial radioactive decay of unstable nuclei, decomposition of nitrogen pentoxide as well as N2O. So, what are the beautiful example for first order reaction? Hydrogenation of ethene, decomposition of N2O5 and N2O, nitrogen pentoxide, and all natural and artificial radioactive decay. So, in physics also it comes under nuclear physics, natural and artificial radioactive decay. Natural and artificial radioactive decay always follows first order kinetics. Therefore, if it is in competitive, if they ask the order of any radioactive element reaction or decay, whether it is artificial or it is natural, it is which order? First order. What is first order? Velocity is directly proportional to first power of the molar concentration of the reactant. First power of the molar concentration of the reactant. Next, I finished about order. Now I am going to molecularity. Molecularity means to know the molecularity of a chemical reaction, just you want balanced chemical equation. Just you need balanced chemical equation. So, if I consider this as a balanced chemical equation, the number of reacting species, whether it may be atoms, ions or what, molecule taking part in an elementary reaction which must collide simultaneously in order to bring about a chemical reaction is called as what? Molecularity. Therefore, to get molecularity, you require complete balanced chemical equation. From the balanced chemical equation, one, you can know that how many molecules are involved, how many atoms are involved, how many ions are involved in a reaction. They must collide simultaneously to bring about the reaction. Molecularity can neither be zero or nor can have fractional value. It is always whole number. Keep it in your mind, my dear student. Order may be whole number, zero as well as what? Fraction. But molecularity is always whole number. It cannot be zero as well as what? They don't have which values? Fractional values. Molecularity is a theoretical value. It is derived for each step of the mechanism. Reactions with molecularity more than 3 are very rare. It is highly improbable that more than 3 molecules will simultaneously collide with one another with the required energy and proper orientation to form activated complex. Reactions with molecularity more than 3 is very rare. Next, molecularity has no significance in complex reaction. This very, very important point. Molecularity has no significance for which type of reaction? Complex reaction. Molecularity only used for which reaction? Elementary reaction. What is molecularity reaction? Is the total number of reacting species. It may be atoms, ions or molecule involved in a balanced chemical equation is known as molecularity. Molecularity is always whole number. It is not zero or fraction. Molecularity is only applicable to elementary reaction, not for complex reaction, as well as molecularity is a theoretical value. To get molecularity, no need of any experiment. To get molecularity, you should know how to balance the chemical equation, because molecularity is obtained from balanced chemical equation, and molecularity more than 3 is very, very rare. Now, here you observe. Now, in this reaction, only one reacting species, its molecularity is 1, therefore it is unimolecular. Here 2 reacting species are involved, therefore it is bimolecular. Here 2, here 1, total 3 reacting species, therefore it is what? Trimolecular reaction. Just it's a reference. When the one molecule is involved, it is unimolecular. 2 reacting species, 2 molecules of reacting species are involved, that is bimolecular. 3 reacting molecules of reacting species are involved, that is known as what? Trimolecular. Now, already I explained zero order as well as what? First order. Now I am going to explain about pseudo first order reaction. 2 mark very important question for your board. Pseudo first order reaction. Pseudo first order reaction. Pseudo, the easy definition is the reaction whose order is 1 but molecularity is 2 or more. The order is always equal to 1 but molecularity is 2 or more. Molecularity is 2 or more. Such reaction is called as what? Pseudo first order reaction. What are pseudo first order reaction? These are chemical reaction whose order is 1 but molecularity is 2 or more, or it also can defined as actual order is different from the expected from rate law or rate expression. Actual order is different from what we calculated from rate law or rate expression. Already I explained that order is obtained by adding sum of powers of molar concentration of the reactant present in rate law or rate expression. What the order we obtained from rate law or rate expression is not same as that of the actual order, not same as that of the actual. If this definition is difficult for you, you use this definition for pseudo first order reaction. What are pseudo first order reaction? These are chemical reaction whose order is 1, molecularity is 2 or more. Okay. The reaction in which one of the reactant is present in large excess shows an order different from the apparent order. For that, I will consider reaction of hydrolysis of ester. It's an hydrolysis of ester. Here I will consider ethyl acetate on acid hydrolysis. Acid hydrolysis means addition of water in the presence of acid. Addition of water in the presence of what? Acid. Okay. Addition of water is called as hydrolysis. If it is done in the presence of acid, it is known as what? Acid hydrolysis. When I take ethyl acetate, what's the formula of ethyl acetate? CH3COO C2H5. When it is hydrolyzed, it will give CH3COH C2H5OH. Expected rate law is K into molar concentration of ethyl acetate into water. Power alli enirutte 1 plus 1 2 ಆಗುತ್ತೆ. But here water is present in large excess. Its concentration does not change during the progress of the reaction. Okay. Here which one is used in large excess? Water. Therefore, ethyl acetate power is as it is 1 but put power 0 to water. Therefore, when you take 1 plus 0 is equal to 1. Therefore, order is 1. Molecularity is 2. Such reactions are called as pseudo first order reactions. Such reactions are called as what? Pseudo first order reaction. What are pseudo first order reaction, my dear student? Whose order is 1, molecularity is 2 or more. Example for pseudo first order reaction: acid hydrolysis of ethyl acetate. Acid hydrolysis of ethyl acetate. In general, one we can say acid hydrolysis of ester is an example for pseudo first order reaction, as well as inversion of cane sugar. Inversion of what? Cane sugar. That is, cane sugar means sucrose, C12H22O11, which on acid hydrolysis water, H plus, it give rise to one molecule of glucose, one molecule of glucose and one molecule of fructose, one molecule of glucose and one molecule of fructose, one molecule of glucose and one molecule of fructose. So this reaction is also called as what? Inversion of cane sugar. Inversion of cane sugar means acid hydrolysis of sucrose, acid hydrolysis of sucrose. It is also a beautiful example for what? Pseudo first order reaction. Pseudo first order reaction. Finally, today in this class, I discussed about two new terms, that is order and what? Molecularity. What are the differences between order and molecularity? Already you know that order is determined by using experiment. Molecularity is obtained from balanced chemical equation. Order is not always whole number, it may be zero or fraction, but molecularity is always whole number. Molecularity is only applicable for elementary reaction, but order applicable for both elementary as well as what? Complex. So I had discussed the difference between order and molecularity. Order and molecular. Order is what? Sum of the powers of the concentration terms in the rate law. It is the number of reacting species taking part in an elementary reaction which must collide simultaneously in order to bring about. This species is atoms, ions or molecule. It can be zero and even fraction, but it is always whole number. Order of a reaction is an experimental quantity, but it is the theoretical quantity. It is applicable to, order is applicable to both elementary reaction and complex reaction, but it is applicable only to elementary reaction. It is applicable only to elementary reaction. Okay. Now, in this class, my dear student, I discussed about order as well as what? Molecularity. Under order, I discussed about zero order, first order as well as pseudo first order. Under molecularity, I discussed about unimolecular, bimolecular as well as trimolecular, and also I discussed about how do you find out order and how can you find out molecularity, difference between order and molecularity, order and molecular. Next session, that is in third session, I'll come up with new concepts of this chemical kinetics chapter. Until that, goodbye. Thank you.